10.3 Geometric Sequences and Series. The objectives. Let's consider this sequence below, 3, 6, 12, 24. What if I wanted to know the 100th term of this particular sequence? What if I wanted to know a formula for the nth term of the sequence? Let's consider this sequence the same way we do a function. So I have listed here in the left column the position of each term, and I have here in the right column the term itself. The first term is 3, the second term is 6, and so on. And just for the purposes of explaining it, let's also look at one more term. The fifth term, hopefully you can figure out that each time you're multiplying by 2, so the next term is going to be 48. The challenge here is if I want to know what the 100th term is, I could easily figure it out if I knew what the 99th term was, but to know the 99th term I need to know the 98th term and so on. But what if I just wanted to jump ahead and I wanted to know when n is equal to 100, what is the value of that particular term? That's the challenge. So let me break this down a little bit. There is a pattern here. Hopefully you agree that 6 is 3 times 2, and 12 is 3 times 4, and 24 is 3 times 8, and 48 is 3 times 16. Working backwards up here, of course, 3 is 3 times 1. So here's a very interesting pattern. We're 1, 2, 4, 8, and 16. You may recall from our study of powers and exponents earlier in the semester that these are all powers of 2. In other words, this is 3 times 2 squared. 3 times 8 is the same as 3 times 2 cubed. 3 times 16 is the same thing as 3 times 2 to the fourth. And backing up, 3 times 2 is the same thing as 3 times 2 to the first, and it even works up here. 3 times 1 is 3 times 2 to the 0. So there's something going on here. We can call all of the terms in the sequence as 3 times 2 to some power. So what about 100th term? 3 times 2 to the power of 99. Hopefully you're seeing that the exponent in each of these cases is 1 less than its position. In other words, if I wanted to know the nth term, I'm going to take the first, 3, I'm going to multiply it by 2 to the power of n minus 1. Where, as it turns out, the 3 was the first term. So an is the first term, 2 is the ratio to the power of n minus 1. And that, my friends, is the formula for the nth term of a geometric sequence. Here you should write down the formula for the nth term of a geometric sequence. Again, reminding you that a geometric sequence is one that has a common ratio, which means you multiply to get to the next term. Later we'll talk about finding the sum of a geometric sequence. Find the sixth term if you know the first term is 3 and the ratio is negative 2. So formula, an equals a1 times r to the n minus 1 power. So the first term is negative 3, the ratio is negative 2. We're trying to find the sixth term, so 6 is going to be n. You need to be careful that you're following the order of operations here, which says that you have to do exponents first before you multiply. Or you can just make your calculator do all the work for you. So this is going to be negative 3 times negative 32, which is positive 96. So the sixth term is 96. First video quiz question. And another example. We want to write an equation for the nth term if I know that the fifth term is 4 and the ratio is 3. Let's write down the formula. an equals a1 times r to the n minus 1. I don't know the first term, but I do know the ratio, and I know that the fifth term is 4, so I'm going to plug that information in. I'm going to plug the 4 in for the an. So I'm going to have 4 equals a1, I don't know, the ratio is 3, and n is going to be 5, since the fifth term is 4. So I have 4 equals a1 times 3 to the fourth power. 3 to the fourth power is 81, so I have 4 equals a1 times 81. So I have 4 over 81 is equal to the first term, and that does not reduce. Now, since I'm trying to find the equation or the formula for the nth term, I'm going to go back and plug in the first term, and of course the ratio, and I'll have my answer. So that answer then is an equals 4 over 81 times 3 to the n minus 1. And that's my formula for the nth term of this particular geometric sequence. Now we're going to find some geometric means. So what that means, geometric means, is the missing term. So there's going to be 3 missing terms between the 3.12 and the 49.92. Now there could be more than one way to think about this particular problem, but this is how I do it. To get from the 3.12 to the second term, I would multiply by the ratio 1 time. To get from the second term to the third term, I would multiply by the ratio a second time. From the third to the fourth term, I can multiply again by the ratio, and from the fourth to the 49.92, I multiply again by the ratio. So basically, 3.12 times 4 ratios, which is r to the fourth, will equal 49.92. And I'm going to solve for r. So I first need to divide by 3.12, and you know what I'm going to get? Amazingly, 16. And then to solve for r, of course, we need to do the fourth root. Look at all this stuff from exponents coming back in this chapter. So r is going to equal plus or minus 2. If we got 2 values for r, that means we're going to have 2 sets of geometric means. So in other words, when r equals 2, then the 3.12 up here that was given to us, the 3.12 times positive 2 is going to give us 6.24 times positive 2 again, 12.48 times another positive 2, 24.96. So there is one set of geometric means. But also, when r is equal to negative 2, you could also have negative 6.24. So that came from doing the 3.12 is the first term up there times negative 2. And then negative 6.24 times negative 2 is going to give you a positive 12.48 times negative 2 will give you negative 24.96. Notice that when your ratio is negative, your signs will alter, the signs on the terms will alternate, negative, positive, negative. Here's your second video quiz question. The formula for the sum of a geometric series is this. S sub n equals a1 times r to the n minus 1 over r minus 1. You should write that down. Let's use that formula to find the exact sum of the first 12 terms of this series. Here's the formula again, and let's plug in what we know. We know that n is 12, since we're trying to find the sum of the first 12. The first term is 8. The ratio, hopefully you can see by looking at the sequence or the series, is 1/2. 1/2 to the power of 6 minus 1 all over 1/2 minus 1. Now, you should be able to work all that out in your calculator. I'll show you in class how you can do that all in one big step using a stacked fraction. It's pretty awesome. It takes a lot of the work out for you. And then turn the decimal that you will probably get into a fraction, and you will get 4,095 over 256. So that is the exact sum of the first 12 terms. When you see the question written this way, exact, it means that they want the fraction. It does not have to be a reduced fraction, but more than likely you will give me a reduced fraction. But what I do not want to get is any sort of rounded decimal. In this example, we're given the sum, but we don't know the first term. So here I wrote down the formula again, and then here I plugged in the information that I knew. The sum is 765, the first term I don't know, the ratio is 2, n is 8, minus 1 over 2 minus 1, ratio minus 1. This algebra here should be pretty easy because especially in the denominator you have 2 minus 1, which is just 1. So I really have 765 equals a1 times 2 to the 8th minus 1. So you need to calculate 2 to the 8th minus 1, and that's going to be 255. So that's a1 times 255 equals 765. And then just divide both sides by 255, and you're going to get 3. The first term is 3. This example I love, and I know you're going to love it too. This time, we know the sum is the 29,524, but we don't know is the value of n. What I've done here is again I've copied down the formula, and again I've plugged in the information that I know. The sum is 29,524. It says right here 1 is its first term, so I plug that in for A1. And it says here that 3 is its common ratio, so I put it here and here. And now I need to solve for n. The first thing I'm going to do is subtract the 1 from the 3 there in the denominator. So I have 29,524 equals, that 1 in the front, of course, is not necessary, 3 to the n minus 1 over 2. I'm going to multiply both sides by 2 to get rid of that 2 in the denominator to have 59,048 equals 3 to the n minus 1. I'm going to add the 1 to get 59,049 equals 3 to the n. Now I need to solve for n. Oh my goodness, what can I do? I have n as an exponent. Maybe I could use a logarithm. I knew it. I knew you were going to love this problem. So we're going to turn that into a logarithm. That's log base 3. Can you believe it? How excited you are? 59,049 is equal to n. Calculate that in your calculator and you're going to get 10 is equal to n. Now you can see why I love this problem. Logarithms, series, geometric, all in one problem. Love it. And here is your third video quiz question.